All right, we're back here. This is number 3 on the problems that I strongly suggest you start to work out. And so, yeah, this is about someone named Upton Chuck. That's probably a joke of some kind. And he's in this thing called the Great Drop at Great America. Yeah, it's a contraption where you sit down in there and then they haul you up to the top of this giant tower with a bunch of cables, and then they just release you and you're in free fall for a few seconds, right? And then they gradually stop you from free falling. So fun, right? I may have done that once or twice a long, long time ago. That looks insane. Anyway, so here the question is, if you're free falling for 2.6 seconds, what is your final velocity and how far will you fall? Okay. So let's write down everything we know here. You're starting off at rest, so that means that your initial velocity is 0. You're in free fall near the surface of the Earth. That means your acceleration is about 10 meters per second squared downward. That way. And you're free falling for 2.6 seconds. So that's time. So here's a question. Can I write on this picture? Oh, yes, I can. Of course I can. So a coordinate system, right? So I'm just going to say wherever they drop you from is like 0. And downward is the positive direction. So if you're accelerating downward and you're moving downward, everything is going to be positive for this problem. I'm positive. So then, look, there are a couple of ways you could work this out. We have this list of 4 equations, but think about it. You're in free fall from rest for that amount of time. An acceleration of 10 meters per second means that every second you're going 10 meters per second faster, right? So starting at rest, 26 meters per second will be how fast you're moving. So V final approximately. Okay, so if you're saying, wait, hold on, how did you do that? Here's how we did this, right? Yes, we have an equation for this. V final is equal to V naught plus A times T, okay? This is exactly what we just said we were going to do, but written out in symbols, all right? You start off at rest. That term is 0. And then your acceleration is about 10 meters per second, which we abbreviate as 10 meters per second squared. And you're doing that for 2.6 seconds. So 10 times 2.6 is 26. And the dimensions here are going to be, that seconds is upstairs and it cancels one of those guys who's downstairs. And that gives you meters per second, which is good. That's velocity. All right. So about 26 meters per second. Now, we're using 10 for the value of little g, the acceleration of gravity. The answers here were calculated using 9.8 meters per second, but that doesn't change the answer significantly, all right? See yourself, all right? You click the See Answer button on the page and you can see the answers, okay? And then the next question is, how far are you going to fall? That's delta x. And again, you could do this several different ways. One way would be to do V average times T, right? So what's V average? Well, if an object has constant acceleration, the average velocity is just the average of 2 velocities, right? Any 2 velocities, provided the acceleration is uniform. So here the 2 velocities are 0 and 26. And the average of those 2 numbers you get by adding them and divide by 2, right? So I think that's 13 meters per second. So there's your V average, right? So then your delta X will be 13 meters per second times however long it was you were falling, 2.6 seconds. Okay, so 13, 2.6. It's about 33.8 meters. 33.8 meters. Okay, and again, you can check the answers in the by clicking on this little button here. All right. So that concludes problem 3. Let's do the next one. All right, so problem 4. You've got a race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second. All right, so you've got your little car zipping along here. The difference here is the car's not starting from rest. Here it's already moving, right? So it has a V naught of 18.5 meters per second. And you step on the gas, and a little while later, you're going faster. So your V final is 46.1 meters per second. And then you're given the time it takes to go from your initial to your final speed. Our coordinate system here is like this, so that towards the right is the positive direction. And so we want to know what's the acceleration and how far did the car move. Okay, so the acceleration, that's change in velocity over time. Or V final minus V naught over T. So your V final is 46.1 meters per second. And your V initial was 18.5 meters per second. And the time it took was 2.47 seconds. So you do the math here, and if you do the math carefully, let's see, what did I get earlier? 11.17 meters per second squared for acceleration. We'll just say 11.2 meters per second squared, rounded off. So that's a pretty hefty acceleration. Again, that's greater than the acceleration of gravity. So you would definitely be feeling that acceleration. Okay, and then next question is, how far did you go? What distance did you travel? Okay, so let's make some room up here. So delta X. Well, there are several ways we could figure out the delta X. One way, yep, we have an equation for that. That is V naught times T plus 1/2 A times T squared. So you could put in all the values, right? We've got V naught, multiply that by time, put in the value we just calculated for the acceleration, 11.2, and do the math here, and that will come out to be about 80 meters. But there's another way to do this as well, okay? That is a little more, maybe a little less math, I'm not sure. How about delta x is v average times t? You could always use that if the acceleration is constant. Right, and so the v average, that's just the average of these two velocities, right? So it's 18.6 plus 46.1, and to get the average, divide those by 2, and then multiply that by your time, 2.47 seconds. And these both have units of meters per second. You end up with the same answer. So there you go. And then I think that's good for now. So we did those two problems, and we'll do some more later this evening. You should work all of these problems, and you should try working them. You really should try doing these by yourself, right, without watching these little tutorial videos. But always, of course, you can look back on these if you need some help. Okay, have a great weekend.